Stream all things, modern data integration. Basically going to talk about how ETL changed and how it's related to stream processing, two of everyone's favorite subjects. I'm Gwen Shapira. Or if you're Israeli, I'm Chen Shapira. I currently work for Confluent, which is the company that does Apache Kafka, and we do a lot of data integration and stream processing things. I wrote a book about that. I'm currently a product manager, formerly an engineer, formerly a consultant. I tweet a lot if you have a 140-character question about Kafka. And also, I'm going to talk about some design patterns. So they all need to have code examples, so you'll see your eyes throughout the presentation, and all the code examples are on my GitHub account. Because there's a lot of theoretical patterns that nobody actually manages to implement, so I figured we may as well implement them. So I'm talking about modern data integration, so let's look at what happened to data integration in the last pretty much 17 years since I started doing that. 17 years ago, year 2000, we had a data warehouse. And data warehouses were fantastic and promised to solve all of our data integration pains for the entire organization, letting everyone see all the data. In practice, it was really difficult modeling data in there. I don't know if anyone here ever worked on data modeling and had this thing where you need to have conforming dimensions and you have to have everyone in the organization to agree on what is a customer. That was super painful. Getting data in was painful, very large processes, doing very large batch jobs that always ran a bit longer than they were supposed to, and that was really painful. Obviously, there's a limit to what throughput you can get through a database, so that was really painful. Somewhere around, let's say, 2010 to 2014, people figured out that this is not working. It's expensive. It's not what they need. Let's do it in Hadoop. So Hadoop is still kind of this batch-only data integration, but now we're doing it completely differently. We're taking all the data from everywhere because the missing data and the modeling problems were painful. Just take the data, dump it in there, somebody will figure it out. Well, the problem is that you now have a lot of data somewhere that someone needs to figure out. Data quality is very suspicious because nobody really bothered checking stuff like foreign key, primary keys, dependencies, all that kind of stuff. Just figuring out what to read, what is the format for the file, what does the column number 17 actually mean, is an exercise to every single developer in the company that wants to use the data. So that was super painful. And these days, people are moving to a model where they use data streams. Where the model is kind of in between in terms of semi-structured types of records. They have some structure, but it's not as rigid as a relational database. A lot more evolution of schemas going on. Latency is very low. That's like the core. We no longer have larger batch jobs. We have Spark streaming jobs. Usually within few seconds to minutes, you get your data. But the whole model of how to do it is just super new. And I think that everyone is really struggling with how to do stuff that they're really used to doing in this new world, this new model. Even like, OK, we have data streams. How do I do a join with streams? How do I, like, a lot of it is something that people are still trying to figure out. Do we use tools? Do we write apps? What's going on? So I'm going to talk about, I go all over the place. I talk to a lot of customers doing this kind of stuff. I just want to tell everyone what we learned is a good way to do this kind of stuff. But first, something to notice that it's not just the nature of the jobs that changed, it's also the people who are doing the jobs that changed. Because it used to be that you had ETL engineers who do those massive data warehouse transformation jobs. And these days, there's very few ETL engineers in places where I work. If they exist, they call themselves data engineers, data plumbers, that kind of thing. I suspected that the core of the change is because if all you do is dump data somewhere and let the developers who use the data figure it out, well, there's not that much stuff to do as an ETL person, and the job kind of like, well, anyone can dump data to Hadoop. Why do we even need this job? So that was like my first theory, but then I looked around in all those organizations I worked with and noticed something else. A lot of jobs went away. So especially with the cloud, a lot of my friends that were storage admins and network admins, they all work for Amazon now. So the software development world changed a lot, and ETL going away may just have been part of this general change. But because the people changed, a lot have changed with it. So engineers don't just write ETL jobs for other people. They usually want to write applications. And the line between writing an application and doing an ETL job blurred a lot. So we had a customer who is basically reading data from a bunch of places, doing some kind of processing on it, whatever, and then writing the results to Elasticsearch. And I looked at it and said, that's an ETL job. And he said, no, that's my recommendations app. You then have this, my website is looking at those Elastic recommendations and showing them to customers. So that's the recommendation app for my retail business. And like, yeah, for me it looks exactly like an ETL, but for him it's actually transactional. The business is running on this thing. It's totally an application. So we have a lot of stuff that's in between. And so developers write those applications. And developers usually are not the point-and-click type. It's very hard to catch developers actually wanting to use Informatica. They're like, we know how to write code. We know how to do it in Python, in Java, in Scala, in everything. We'll just write something that gets data from here and puts it over there. So that's kind of like how things moved around. The patterns we'll talk about is, first of all, how everything is streams and what it means about data integration, about data compatibility problems and how some people solve them, how to do very fast parallel data integration, and then streaming data enrichment. And obviously, there's probably no time to talk about even half of it, so we'll see. So I'm going to walk through imaginary large hotel chain. I worked with like 3 of those in the last year, so I've seen a lot of hotel-related examples. And those hotels have a lot of data. And when I show up, I tell them, like, all your data is streams of events, every single bit of it. When people go around your website and look at different hotels, definitely events, right? You click streams, you get those page views. If people do website search, that's an event. When people book an hotel room, that's an event. When people show up at the hotel and check in, that's an event. When they walk into the hotel room and they open the door, they slide this card, well, that's an event, right? They definitely gets recorded. When they go into the room, they watch TV, they flip channels. This gets recorded because someone needs to know which channels are not being watched, and maybe we should renegotiate the contract with the TV provider. Opening the minibar, getting a beer, definitely an event. So all those things going on are events. If someone changes his profile in a database, this is also an event. The very fact that someone did insert into or update. Lots of events, everything in the organization can be modeled as large streams of events. Let's look at one of those streams. We talked about those page views being done on the website. So we record those as a stream of events. And those events may look a bit like that. You know, they have a session ID, they have a timestamp, they have which property you're looking at. You have the fact that you're looking at some kind of a property. And they also have information on how you got there. So there's a lot of information in those page views being captured. And there's a lot of applications that you can build around those streams of events. And pretty much all of them are real things that I've seen people build. Like 15 other people are looking at this property, so maybe hurry up and book a room because it will be gone. A/B testing, who is doing what kind of design is doing what. People who searched for this kind of hotel also use the other kind of hotel. Affiliate programs, you know, when you use a blogger says how awesome the hotel is and gets money every time someone books stuff. Lots and lots and lots of applications, all running off this stream of events. And since you have a lot of stream of events and you have a lot of applications, there is a potential for something very messy. This is a pretty famous diagram from LinkedIn, but to be honest, the reality is 100 times worse because we have here, what, 20 services? If you have microservices, your organization can have thousands of them. They actually usually do. LinkedIn has a lot more these days as well. So you have all those events going through, talking to each other from system to system. This system needs this data, the other system needs the other data. A lot of organizational overhead goes into just connecting things to each other. Every time you have something new, where do I get my data? How do I get it? My husband works at Facebook. It feels like 100% of his time is, oh, I'm just connecting this thing to these 15 other things, because when you're a big organization, that's how life is. And at least part of the pain is because traditional ETL really doesn't, while it does have a stream of events that it reads from one place and writes to the other, it never lets you really access the stream. The stream is not really a first-level object. So you have this, I don't know, Informatica or something that data gets out of this database to the other database, but it doesn't let any of your applications that really need the same data. They also want to know when a profile, user profile change. They don't let him see it. So you have to keep connecting more and more things to the same profile database because you don't have a good model that lets you access the data as a stream. So our suggestion is that you need something that knows how to treat streams as a first-class object. It's not just a byproduct of connecting something to something, but you model because everything is a stream, you can model things as streams of events, and then have different applications write to it, and different applications consume from the stream, and they are decoupled. They are completely independent of each other, which has a lot of good organizational properties as well. And the reason this all works, I'm going to skip it very quickly and just assume that you all either know Kafka or know how to look for Apache Kafka, is that a stream of event is basically the same as a log, and Kafka is a system that was written. It was written originally as a pub subsystem, publish, subscribe, but it was modeled internally as a log of events. Basically, you publish, and events get written one after another, and then when you consume, you always consume events in order. But of course, we need to scale, so Kafka has the concept of different topics. You publish to a topic, you subscribe to a topic, but the topics have many partitions, so each one of them a partition is basically the stream of events. And so if you go back to the page view event, we basically have page view event topic. Producing to it is probably your website application, your mobile application, and if you have any other things that knows how to allow people to view your website. And then you basically connect a lot of different consumers to read from this topic. So far, so good. These are different teams. They never talk to each other. They don't care about each other all that much. They just consume from this stream. Very common story. At first, I thought it was just my idiot customers, but that actually happens quite a lot. You write those events to the topic. You have all those systems consuming from topics. They make assumptions about the data, right? They assume the timestamp is a log, and they write code based on timestamp being a log. Well, if someone decides that, hey, I can't really read a log, it's really stupid, let's put a string and have people parse the string, immediately everything that downstream for that will completely blow up, right? Your create table, inserts will no longer work, your parsing in the application will no longer work. And this happens over and over again. Uber had a good talk with the exact same story, and they did it completely independent from me. This story, I think, the original one is from Monsanto, and there was like 5 different companies that did the same. So pattern number 2, in order to keep those streams processing and churning, we have to make sure that nobody upstream suddenly breaks compatibility. Super important, and I feel like it doesn't get enough attention. Developers care so much about the APIs and compatibility of the APIs and testing the APIs, unit tests and everything to make sure that stuff doesn't break, because those are contracts. Those is what 2 services guarantee to each other. But if you do decoupled services that talk via a stream of events, well, the event schema, the data types in the event themselves are the APIs. So you need to be very careful about how you manage them. And you really need to tie it into your development process. So you want to make sure that, can you read anything? Yeah, that's pretty readable for you. If you do, for example, a commit to, or a pull request to Git, it will be nice if something in the background can check, oh, you changed the schema, is it compatible, not compatible, and kind of do a continuous integration check mark, OK, compatible, X, not compatible. Or if you can't go within Git, maybe in your Jenkins job doing continuous integration, if that doesn't work, maybe you have a test system, or maybe it's staging, or in the worst case scenario, something in production should be able to check, hey, this is not compatible, because I have a list of all the schemas, but now you have a new one when I compare them, and you just modify the data type, and it is going to break stuff. And in Confluent, we have the Schema Registry that basically does it for you, both in development and in production. It allows you to basically store all the schemas, and either when you're developing, compare things, or before you're producing events to Kafka, it will basically throw away the bad events. OK, so far for compatibility. Ridiculously parallel data integration. It's the insight that huge parts of data integration problems can be done on single events. There are no joins, there are not aggregations. They can be done by just looking at one event at a time. And that can be massively parallelized, right? Because if you have 1 million events, in theory, you can do it 1 million processes doing it completely in parallel. The example here is that you're replacing a credit card with something, but you have a lot of examples of stuff that you just need one event in order to figure out. Unit conversion, filtering, all this kind of stuff. And there's the notion of hipster stream processing, which is basically a small application that reads events from a topic, does something small to it, and doing something to a single event is very small and very easy, and you write somewhere else. We call it hipster because hipsters have those fixie bikes that are very simple and very convenient, but you can't take them uphill. So as long as you're in flat ground, they're perfect, they're really nice. Like in Tel Aviv, go for it. Here in Jerusalem, maybe not that much. Same thing, the hills in stream processing are joins and aggregates and everything that requires a state. So you can do it event by event. So as long as you do it event by event, you can be massively parallel, and then you need something very small that just a consumer, something, and producer that does it. And consumers in Kafka are super scalable. We have the consumer group model, which basically allows you to start with single consumer. It will read from all partitions in the topic. You add a second consumer. They will automatically, without any work on your part, just divide the work between them. Kafka has a fantastic magical protocol for consumers to negotiate who is doing what work. It's responsible for load balancing and high availability. So if one of those crashes, the other gets the partitions that were left behind. So that's kind of the trick, and that makes it very simple. Again, consumer, processing, producer, very little work involved. And then if you're connecting databases, because we talked that you can actually do data integration of databases and applications and more databases and more applications, we also have Kafka Connect, which is kind of a framework that has a lot of built-in connectors. That's a small list. We have 50 of them. And you just plug stuff in, and you basically get a stream of events out of a database for pretty much for free. And that allows you to have either write it to another database or to an application. So by making streams something that's first class, you are no longer limited to ETL one database to another database. You can do ETL that involves applications and databases, which is pretty cool. I'm going to totally skip how Connect works, and which is a shame because I worked really hard on this animation. And move to another example. So this example is our hotel wants to do a promotion. We want to take all Platinum members who are currently looking at beach properties for their vacation and tell them about a new beach property we have in Hawaii. Because if they want to go to the beach, I guess Eilat, Hawaii, Tel Aviv, more or less all the same. So we may as well tell them about a discount. So this means that we have this page view event we talked about earlier, and it has stuff like session ID and timestamp and the loyalty number and property. But we really need to enrich it. We need to know, is it a Platinum member? Is it looking at is this property at a beach? So we need to kind of do a join of stream of those page views events with some tables. And logically, we want to have those events, and then we want to enrich them somehow. Use this enriched information to drive a decision, maybe record a decision in Elastic, produce the result of the decision, and feed everything to kind of a topic that sends off the promotion emails. Fairly simple if we only knew how to enrich things. So our first attempt at enriching things is, well, we have a database or maybe a service with all this information. We get an event. We'll call the database and say, hey, is this a Platinum member? Hey, is this a Platinum member? Hey, is this a Platinum member? Not bad. If I had a small system, I would still probably do stuff that way. But there are some issues. So obviously, latency is not really where you want it to be. The throughput is probably not going to be amazing either. Kafka can do, even in a small cluster, 1 million events per second is fairly easy. In a database, you probably want to look, I mean, your DBAs will kill you if you do more than 1,000 per second. So there's like 3 orders of magnitude difference that is going to be a bit hard to reach. And then also things like retries and the availability of the service, it gets a bit complicated. And if you get a late event, if like for some reason something went down and you get a page view from 5 weeks ago, what you have in the database now may be completely irrelevant. What we really want to do is join a table with the current state of the world to a stream of events. So how do we join a table to a stream? Well, we turn the table into a stream. So basically, what we really want is to cache the table locally. It doesn't take that much space, and to do the joins in memory. But that means that it's really hard to keep the cache up to date. How do you know when to invalidate? If you ping the database too often, you have the same problem again. If you ping the database too rarely, well, you're going to have stale cache. Stale cache is absolutely terrible. You make bad decisions. So you turn the database into a stream of events. It's called change data capture for those of you who come from the old school ETL world like I do. And it basically means that instead of looking at the table and seeing what it is right now, you get all the updates, inserts, etc., as a stream of events, which allows you to update the cache in your application. And now you can do this join that you always wanted to do. So we use the Kafka with connect, the CDC connector, to turn state in the database into a stream of events. And then we take the stream of events and turn it into a state in the cache itself. So this is pretty much what it looks like. We have the state. We have do change data capture. We get the update and inserts. And then we apply the update and inserts onto our cache to get the state again. Now, in reality, this kind of thing is not as trivial as you would like it to be. For example, persistence is really difficult. What if you have a state now? What if your machine crashes and something recovers? How do you replicate the same state in the cache and continue on? Failover recovery, partitioning things correctly can get really hard. Kafka streams, and probably other stream processing as well, but I'm not familiar with them, make it really easy. You basically have create a table from a topic and do a left join. And that's pretty much it. And again, I have an example, so if you don't believe me how easy it is, there is a long blog post on how to do it and how it works underneath and how they do all the crazy stuff to make it happen. Whew, OK. So we talked about how everything is really a stream, and you can use Kafka to manage them. We talked about compatibility. We talked really fast about single message transformations, which are fast and parallel. And we talked about a cool trick for doing data enrichment. So I think I fulfilled my commitments even 2 minutes early. Thank you.